In this section of the book, we study regression models. Now, there's many reasons as to why people might estimate a regression model or think about a regression model. The most common reason being wanting to estimate the effect of one variable might have on another. In this book, we explicitly focus on using regression models for forecasting. So we want to use some predictors, and we are interested in predicting some other variable. What does a regression model look like? On our left-hand side variable, we have the variable that we're interested in forecasting. We usually refer to this as the response variable or dependent variable. On our right-hand side variable, we have, on our right-hand side, we have our predictor variables, which we usually assume that we know all the past and future values, which is not usually the case, especially with future values, and we'll talk about that in subsequent sections of the book. To actually make this model operational, we need to estimate, and we are interested in estimating these coefficients. This β naught is the intercept, and the rest of the coefficients show the effect or measure the effect each predictor has on the variable we're trying to forecast, on the response variable, taking into account the effect of all other predictors. Hence, we refer to these as marginal effects. So this β1 is the marginal effect of x1 on y. So the effect of x1 on y taking into account the effect of all the other variables. Epsilon t is a white noise error term, and we'll talk about the assumptions we make about that in a couple of slides' time. Now let's think about a simple example, and the simplest example is to think about predicting a variable y using only one predictor, and that's the framework of simple regression. So in this case, we think about US consumption expenditure as a percentage change of US consumption expenditure using income, the percentage change in income as the predictor. So plotting these two time series, we see that there's some common features or common patterns, and hence it may be a good idea to try and predict consumption using income. Another way of looking at this, or possibly a better way of looking at these variables, is to actually look at a scatter plot of consumption on our y-axis. This is the variable we want to forecast, and income on our x-axis as the predictor. We are not thinking about causality here, and if you're doing economics, you may start thinking about various issues. Here we are purely interested in forecasting consumption using income as our predictor. So we look at the scatter plot, and there seems to be some positive relationship between these two variables. Now, if you've done any regression using R, you'll be familiar with the LM function in this book, and we will use the TSLM function, which is inbuilt in Fable. And the reason we're using this is that the TSLM function has some inbuilt features for time series analysis, which helps us with forecasting. So as we will use the TSLM function within the model function, and the way we specify a regression model, the syntax is we have our y variable, consumption, followed by our x variables on the right-hand side. Notice that although I haven't specified an intercept here, an intercept is always estimated by default, and we'll talk about the intercept later on as well, unless you tell TSLM not to estimate an intercept. Now, a more interesting example, I guess, is to move from simple regression to multiple regression and consider multiple predictors for forecasting consumption. So we've got several variables here: income, production, savings, and unemployment. And looking at these time series again, we can see periods where we have sort of common movements in these variables. Again, a better way of looking at this is looking at scatter plots. This is using the ggpairs function within the ggAllY package. And we have across our diagonal, we have densities or smooth histograms of the variables. So this is density of consumption, income, production, and so on. Across our x-axis, we have across our columns, we have the variable that sits on the x-axis, Across our rows, we have the variable sits on a y-axis. So across this first column, we have the relation between consumption and all the other variables. So looking at the scatter plots, we can see some strong positive relationship here. The actual correlation coefficient is shown on the cell opposite the diagonal. So this is a symmetric matrix. So the correlation between consumption and production is 0.529, the correlation coefficient. The correlation coefficient between consumption and unemployment is negative 0.527. Of course, looking across the other columns, we can see some relationships between the predictors themselves. So income and savings is highly correlated, 0.72 correlation coefficient. Production and unemployment is highly negatively correlated, 0.768. Okay, so we've looked at some variables, and now before we start estimating a model, we want to talk about the assumptions we make with a linear regression model. I guess the first implicit assumption that we make is that the relationship is linear between y and x. Now, further to that, we're going to make some assumptions about our error process, and the assumptions we make is that our error process has mean zero, hence unbiased forecast, and our errors aren't correlated, hence efficient. We don't have any more signal left over in our errors that we should take advantage of. And we also assume that our errors aren't correlated with each of the x variables. Now, this is a little bit, harder and may be violated, especially in the cases where we have omitted variables, where a variable might be correlated with both the response variable and the predictors, and hence we get this assumption to be violated. It is, for forecasting, it is also useful to have the errors being normally distributed, and it is useful to have this assumption when we are producing prediction intervals or outside the forecasting realm where we are doing inference, where we're doing statistical tests. In the next video, we're going to talk about estimating these models.